In this video, I'm going to be talking about what free fall motion is and some main concepts and applications of free fall motion. Now, I'm going to talk about a few main foundational concepts in order to have a good understanding of what free fall motion is in order to transition to some problem solving. If you are interested in seeing some videos for problem solving, click at the playlist at the end of this video and you'll see some free fall calculation videos. All right, so let's start off with taking a look at two different masses. We have one large mass and one small mass, and both of them have a force of gravity because the Earth is pulling down on both of these objects. So basically, what free fall motion is any object that is only under the influence of the force of gravity. So typically that's something that's moving through the air, but actually just neglecting the air resistance. So something could be dropped, it could be going upwards, it can be moving in an arc, such as this purple arc over here. But if the only force acting on it is force of gravity, then it's considered in free fall motion. So one thing to know about free fall motion is that it makes every mass have the same acceleration. That acceleration due to gravity is negative 9.8 meters per second squared. Now, a common misconception is that larger or smaller objects may have a different acceleration due to gravity, but that's only if air resistance is present. If there's no air resistance present, then the influence of gravity is similar to where it develops an acceleration of negative 9.8 meters per second squared. Now, that confuses a lot of people because they're wondering, why would a heavy object not fall faster? It's because of this. Something that has a greater mass has greater inertia, which means that it has more resistance to being accelerated, which means it's a little bit harder for the Earth to pull something larger down to its surface. So, number one, it is harder to pull, but it does have a larger force that it's pulling it down because of the amount of mass of the actual object itself. For a smaller object, it has less inertia, which means it has less resistance to accelerating and moving downward, but it has a smaller force of gravity pulling it down because of its smaller mass. In the end, the effect is going to be the same, causing it to accelerate at negative 9.8 meters per second squared. So, what does that mean? That's the rate that it changes. So, no matter what's happening, whether it's dropped or thrown, as soon as it goes into free fall motion, which means that there's no hand pushing it or air blowing on it, then the acceleration is going to be negative 9.8 meters per second squared. So let's take a look at our second case over here, where we have something going up and down. We have some positive velocities showing that the object is rising upwards, and then as it comes downwards, those are called negative velocities. Now, as it's rising, because it's going in the opposite direction of the force of gravity, obviously the force of gravity is always directed downwards towards the center of the Earth. Because that FG is always directed downwards, what it's going to do is cause that object to slow down the entire time it's rising until it reaches an instantaneous velocity of 0 meters per second at the top. Now, at that instant, it starts getting pulled downwards and it gets a negative velocity. And now you see that force acting in the same direction as the velocity. So, since they're working together, now it is accelerating in the negative direction. And this time it is actually speeding up. So anytime something is moving away from the surface of the Earth and away from that pull of gravity, they're working against each other, causing an object to decrease its velocity. Anytime it reaches its peak, its instantaneous velocity is 0 meters per second. And then when it moves downwards and the velocity and the force of gravity are working in the same direction, it causes something to speed up and have a greater and greater negative velocity. If something returns back to its initial height, then that initial velocity is going to equal that final velocity, except the only difference is that final velocity is going to have a negative in front of it because it's going downwards, not upwards, as this initial velocity is. Now, the last thing I want to talk about is what happens when things are arching like this. Okay, Now the same thing is happening. It's under the influence of the force of gravity and no other forces. So how does it arc like this with only a force going down? Why isn't it moving downwards or just straight vertically? Because it has the initial inertia from the force that propelled it up into the air. So, say for example, it's a soccer ball that is kicked upward at an angle. That means it has some vertical velocity and some horizontal velocity. So, it's going to do everything that is going on over here, which means it's going to be rising and slowing down and then coming down and speeding up. But as it's doing that, it has some inertia in the horizontal direction. Now, that horizontal velocity is not affected by the force of gravity because it's acting in horizontal and not in the vertical direction. So, that vertical component of its velocity will slow down as it rises, and it will have a instantaneous vertical velocity of 0 meters per second at the peak there. So I'll say 0 meters per second just in the up and down direction, but it's still scooting over sideways the entire time. So, although it is scooting sideways, it still has those same effects from the force of gravity causing it to slow down and speed up. Okay, to sum things up, so free fall motion isn't necessarily something moving downwards because the word fall does tend to cause most people to think that something is moving downwards. It could be moving up or down. The mass of something is insignificant if there is no air resistance, which free fall motion is always ignoring air resistance anyways. So if something's under free fall, everything has that same acceleration of negative 9.8 meters per second squared. As something is rising or falling, then it's always going to have that same effect, as in it's always going to slow down as it rises, it's always going to speed up as it moves down. And then when things are arching in that two-dimensional type of motion, it still experiences the force of gravity in a similar way, but because it has inertia sending it sideways, it will create some sort of arc. So I hope that was helpful in helping you understand the effects of the force of gravity and free fall motion. Thank you for watching and listening.